All right, so let's get started for today's workshop. My name is Mihir Thakkar and I am the founder and instructor at Code. A lot of you have been to our previous sessions and some of you might have seen our past videos. So first, let me tell you about Code Heroku as well. If you haven't been to our past session, we are an online programming platform and we host live and interactive sessions like these where students can come and learn in a live project-based class instead of looking at a video on YouTube. What you could do is be in a live session with the instructor and where we walk you through a project-based class. So this is an example of where we'll be using machine learning to build a real product or a movie recommendation algorithm, which is pretty much as we'll see is used in so many different places, or so many platforms use a movie recommendation engine. So let's see what we're going to see in today's session. Today we are gonna, because a lot of you have said that you haven't seen any of our past videos or workshops, I'll do a quick recap of what we have covered in the past. And if you know anything about machine learning, or even if you don't know, don't worry. I'll try to recap a few things. It will be pretty basic, and then we'll study some things about recommendation systems in terms of we'll see some theory behind them, and hopefully that will give you a better sense of what are the different options that you have, or what is the work that has been already done in this field, so that you get a sense of where the innovation could come, or where you can improve those systems. And we'll also do some math, as a lot of us are software engineers who might not come from a mathematical background. Let's say what we are going to do is we'll try to see some math behind the concepts that we're going to see, so that it's not just a black box, what's happening behind the scenes, and we are not just using these libraries and not understanding the math behind them. And obviously we're not just gonna keep talking, we'll go hands-on and we'll build a recommendation engine in Python using Scikit-learn as well. Okay, so let's get started with some recap of our previous workshops. In the first lecture, we have seen these are the stages that are involved in a machine learning pipeline. The first stage in any machine learning pipeline is to extract and clean the data. And what are the tools which are available to extract and clean data? Well, you could use scripting languages such as Python, Ruby, or even shell scripts. And sometimes you need to scrape things from internet, so you end up using something such as Selenium. So these are all the tools, not comprehensive list, but just a glance of what tools or scripting languages are used. So the first thing is to extract and clean the data. Most of the real world data out there is very dirty, and it's it's not literally dirty, but it's more like they have a lot of missing values, and you need to harmonize and clean the data before you could actually use them. And once you have that data, you need to start building the model. And these are the tools which are available with us to build a model. So you could use something such as Scikit-learn, which has some implementations of the model algorithms, or you could use third-party APIs such as Azure ML or Google natural language APIs, or you could build your own model in TensorFlow as well, right? And today we are going to focus on this part. We are going to see how to build a model, and we're going to focus on that. We are not going to literally build a model as such, a machine learning model, but we're going to focus on the machine learning aspects of it. And the third stage, which I skipped over quickly, was building the software infrastructure. So for example, even after today, once you build a recommendation engine, it will be still a Python script. It is not something that you could give your users and they'll be able to use it. But as a as a software engineer or a product developer, you need to build the entire product which has the machine learning components in them. And to build the software infrastructure around your machine learning algorithms, you need to know a bit of JavaScript, Ruby on Rails, or know something such as Web2PY that we have used in our previous workshops. And to collaborate with other people, you need to know GitHub, or if you want to know deploy to the cloud, you end up using something such as AWS or Azure. So this is like a very high level view of what are the steps involved in machine learning. And a lot of you ask me, what should I do if I'm a beginner in machine learning? What things do I need to study? And well, pretty much these tools are right in front of you. Once you know how to extract and clean the data, and you know how to build a model and test and verify it, that's it, right? Now that is pretty much what it is to being a machine learning engineer, or what it takes to learn machine learning. All right, so the next thing that we had seen in our last workshop was supervised machine learning. And within supervised machine learning, we said that for example, let's say someone gives us this data set. As we said, the first step was to get the data, extract it, and clean it. So given this data set this is a data set of house locations with their number of years, how old that house is, the size of the house, and the price in lakhs of rupees, right? And once you are given this data set, your job as a machine learning engineer is to predict what this price is going to be for these two houses given these parameters, right? So you need to find out, or you need to predict these two values. And to do that, what you could do is build a supervised machine learning model, and this model is going to predict what the price is going to be for these two cases. And just to give you some semantics, these data sets which are given to us are called as training data points, because these are the points which we use to train our model. These points which we are testing our algorithm against are called as test data points, right? Because we want to test and validate our model. And these parameters over here, or these columns over here, are also called as the features of our machine learning engine or machine learning algorithm, because we are using these features to predict our target value, which is the price over here, right? So just so that everyone understands and know, if you haven't even been to any other machine learning class, these terms such as features, training data, and test data should be very familiar to you now. Okay, I won't spend a lot of time on it because we need to quickly go into the recommendation engine as well. But if you have any questions, please ask them right now on the chat, so that it's not just me rushing through the content over here, but I want to make sure that you guys had some background on what we have covered in the past, and thus these two slides. So please be sure if there is something which is not clear, or if you have any questions, please ask them on the chat window. All right, so I don't see any questions over there. Let's move on to the next part. I have a question for you. What do you see on the screen? What's common in between these two pictures? Please send me your answers on the chat window. So Naman says they are recommendations, of course. What else? Does everyone agree with what Naman is saying, that these are recommendations, or no, is there something else to it? Yep, Suman says they are recommendations based on the past. So both of these platforms, Amazon and Netflix, need to cater or serve the users, and they are trying to give the users a better experience, and they're trying to point out to the user what's most relevant to them. And now this could be based on their past their past behavior on their platforms, or it could be based on the users who have similar profile to this given user, and they would recommend things like some things which your friends like, or something like that. So both of these images over here are a very popular examples on how recommendation systems are used in real world. They are pretty much used everywhere. In the olden days, when you used to like walk into a shop, and in even now, it's not just it's not a thing of past, but still we recommendation systems are more common when we talk in terms of web platforms or mobile apps. But even in the olden days, when you used to walk in a shop, the shopkeeper would ask you some of your preferences, and based on the types of items that you're pointing out, he'll suggest similar items to them. Once the shopkeeper knows that you don't like a pink color shirt, he's not going to show you another pink color shirt, right? So that's the basic idea behind it. For an online store or an online marketplace, they need to find out things which are most relevant to you. And in any such platform, if you're working for a startup, it's highly likely that you're going to come across a recommendation engine that they need to deploy. So it's a pretty popular and widely used technique, and I hope that we are able to cover that today. So these are some examples of how recommendations are used in real world. And let's see some types of recommendation systems. And before we look at the types of recommendation systems, I just wanted to reiterate on what I said just before. For any recommendation system, there are users of that system, and there are some items. In this case, let's say it's Netflix. Now the items in this systems are the movies that they need to match. So what a recommendation system is going to do is, given a set of users and given a set of items, it is going to make that matching. So it's just like you're doing the match the columns in our school days. We used to match the columns, and this is what we are doing over here as well. We are just matching the users to their most appropriate, or the items that they might like, they might buy, or they might watch, or something like that. Okay. So this is the basic idea behind recommendation systems. Quick quiz so that I know that you are getting this point. Who are the users and items for the recommendation engines in the following platforms? For LinkedIn, so we'll go all of these one by one. So let me know in the chat, what do you think? Who are the users of LinkedIn, and what are the items that need to be recommended? Let me give you an example. For LinkedIn, users are the members of that platform, and items are also the members, right? Because they need to match people who you might know or who you might be working with. So users are members and items are members as well. For Amazon, what do you think it might be? Who are the users and what are the items? So Santosh says users are the members and items are the products, right? Yes, that's correct. So items are the products, example, books, electronics. For Netflix, I think you already saw this, but still go ahead and let me know. Who are the users and what are the items that they are trying to recommend? Yep, members and films, or any web series that they are Netflix originals, or anything that they want you to watch. And for Facebook, who are the users and what are the items that they are trying to recommend? Yep, members and members again. It's a social network. So similar to LinkedIn, you will have friends that they are trying to recommend, or no, based on your profile, they are trying to recommend other people who you might know. Yep. So I think that was just a comment from Shanmukh and not a question. So we'll move on to the next part. So let's see, how would you go about implementing a recommender system? The first, very obvious one is to do a popularity based recommendation system. So for example, on Netflix, you might see something like trending over here, right? So how are they getting this trending feature, or no, this trending list from? Based on what users are watching, right? So if they see that a web series or a film is getting very popular these days, just by keeping a track of how many people are watching it, if they see that this new web series has lot of clicks and they are getting a lot of view times, they might just pull it to the front, and based on the ratings that are provided, they might say that, you know what, these are trending, so you might want to watch it, right? So the first one is the popularity based, or it's the most simple algorithm that you come with, and surprisingly it works pretty good. It's not a, just because it's simple, it's not bad. A lot of platforms use it, and you might combine it with other recommendation strategies to improve your algorithm as well. So the first one was just have something like a trending list, or something which is getting very popular. And to do that, there is no rocket science behind it. It's just you keep a track of how many users are watching that, and you just arrange all your items in descending order of the count. That's it. All right, so let's come to something which is more interesting for us, which is the second one, which is the content based recommendation systems. And in a content based recommendation system, what you do is, let me get a pointer over here. So what you do is, you have this user who has, you have this item or a book or a paper that this user has already read. Okay, so you know that this user has seen it and read this book. So once you know that user likes this item, what you could do is find all similar items to this item. And how you going to find that similarity? Based on the content, right? So you might dig into the words of these books, or know what are the sentence, who are the author, who is the author of this book, or what's the publisher like, or what's the genre. So based on those features, or those attributes, you will find other items which are similar to this item, and then recommend them back to the user. And this is the content based recommendation system which we are going to study today, and we'll be focusing on, and we'll be implementing this type of system. We'll be taking one input movie from a user, and we'll find all other movies which are similar to this movie, and we'll recommend them back to the user. Okay. And the third one is something which is made popular by Netflix. It's called collaborative filtering. This is essentially like peer-to-peer suggestions. So you know that these two users are similar. User A has read the green item, and you know that these two are similar because user B has read this item as well. And now you know that because these two are similar profiles, if there is another item which is read by her, this user might like it as well. So this works both ways. So if the blue person reads it, it will be recommended to this girl, or vice versa, right? So it's pretty straightforward, and most machine learning algorithms that you would come across are, the logic behind them is pretty simple. It's just that how do you scale them? And essentially the reason why you need to keep it simple, because it needs to scale. Like once you are running algorithms which need to run on 1 million or 10 million data points, the scaling factor becomes very important. So the algorithms are pretty simple, and the math behind them is not rocket science as well. You just need to be able to scale them efficiently. All right, so we are going to focus on this content-based recommendation system. And again, what we are going to do is we'll take a movie that this user likes. We'll find other movies which are similar to this item and then recommend it back to the user. Okay. So let's see. Let's dig into some details now. We have been talking at a very abstract level until now. So let's see some details. Over here, I have two sentences, text A and text B. And our job is to find the similarity between these two pieces of content. So how do you think, what are some approaches that you can think of? You could come up with a similarity score between these two texts. So can you guys think of some ideas? Or so first of all, tell me, are these two similar or not? And based on what do you think they are similar? And again, to keep it very, very basic, these are not proper English sentences as well. I just wanted to show you some math behind it, and to keep it very simple, and to keep it in 2 dimensions so that you could visualize it properly as well. I had just had both these sentences have just 2 words in them, right? And that's the reason behind I am trying to keep it very, it's not even a proper English sentence, but think that these are the 2 sentences in 2 documents. You have the document A, which has these text, which is London, Paris, London, and the document B has Paris, Paris, London. So based on this, what do you think? How similar are these 2 documents or these pieces of content? And now, based on what do you say that? So Santosh, we don't know that this is location. For a machine learning algorithm, these are just words, right? It's just plain ASCII characters coming together. So Suman says common words. So yeah, there are some common words between both of these texts. Words are the same, then we can say yes. So again, these 2 are similar content. They are not exact sentences, right? But obviously, even if you ask a 5-year-old kid, he'll be able to tell you that these 2 pieces are similar. And based on what he's going to say, because he finds similar words in both of these documents or texts, right? And which is Paris and London, right? So now our job as a machine learning engineer is to quantify the similarity. Now, how can we mathematically come up with a number or a score which gives us an indication of how similar these 2 scores are? Okay, so let's see how we are going to do that. We are going to come up with a number in a mathematical way to come up with a score which denotes the similarity between these 2 pieces of text. Okay, so essentially what we need to do is come up with distance between these 2 vectors, and don't get scared by when I say vectors. We are just trying to represent them on a graph. Both of these sentences will represent them on the graph. And again, over here, we just have 2 axes over here, London and Paris. And can someone tell me why do we have just 2 axes, or why did I say that I have just 2 dimensions, London and Paris? To represent, we don't need any 3rd axis over there. Again, look at this sentence over here, London, Paris, London, Paris, Paris, London. And over here, I have drawn only 2 axes, or London and Paris. why do I just have just two axes? Can't I have like a third Z axis with something like New York? Yeah. So Santosh and Abhishek both got it right. There are only two words in the entire no both of these documents. So we just need two axes over here, right? So which is London and Paris. So if you have more words, you will have more axes, okay? Or no, you will have more dimensions. So once you know that there are only two words over here, what you could do is, you can count how many times the word London appears and how many times Paris appears. So in the first line, text A, London appears 2 times and Paris appears 1 time. In the text B, Paris appears 2 times and London appears only 1 time, right? So given that you have this count, London is 2, Paris is 1, London is 1, Paris is 2. Can you denote points on this graph? Can we denote points on this graph 2, 1 and 1, 2? Yes, of course. So what you could do is we can draw two vectors over here. The first one is for the text A, which will go from 0, 0 to 2, 1. And this is text B, which is going from 0, 0 to 1, 2, right? Because we know that this point is 1, 2. So now that we have mathematically or we have graphically represented these two vectors or these two texts, can we find the distance between these two texts or these two vectors? And can someone tell me how would you go about finding distance between two vectors? And we have seen this in our 12th grade or even for some of you even before that, right? How would you go about finding distance between two vectors? Well, because this is a revision class, let me just show you. So yeah, using Pythagoras theorem, it will be a tedious thing. You will have to derive everything right from cosines just to give you the final result that you will come across. Everything starts with the Pythagoras theorem, but eventually you will end up with this. So what you could do is, there are two ways you could find distances between, or there are a lot of other ways, but primarily there are two distances over here. The first is the angular distance, which is the theta between these two vectors, and the other is what we call as the Euclidean distance, right, which is the distance between these 2 points over here. So now again, a very basic math question. Just by looking at this graph, can someone tell me what the Euclidean distance over here? No, it's very obvious. Use the Pythagoras theorem right over here and tell me what's the Euclidean distance d for this between these two vectors. So I'm not getting any answers. So let me go ahead and quickly tell you. So again, let me give you a hint now. So imagine there is a triangle over here, right? There is a triangle that you can see. Now this is 1 and this side is 1 as well. So what's d over here then? There is a right angle triangle over here with two sides 1. So what is going to be the hypotenuse? So what's the hypotenuse going to be? Yep, Biswajit got that right. It's going to be root 2, right? So it's going to be a 45, 45, 90 triangle. And the hypotenuse is going to be root 2 then. Okay, so that's one distance. Finding theta is little bit more complicated than that. For theta, what you could do is start with cos theta, because you know that cos theta is the dot product of these two vectors divided by product of their magnitudes. Again, the magnitudes you can get from here. These are the lengths of these vectors are the magnitudes, and if you divide the dot product of these two vectors by the magnitude, you will get cos theta. And if you get an inverse of cos theta, you will get the theta, right? So for machine learning perspective, we are not really interested in the theta, but even if we get cos theta, it's good enough for us, because cos theta will range from 0 to 1. So it will give us a nice indication on the separation of these two vectors. So we'll get a numeric quantity between 0 and 1, which will give us an indication of how apart these two vectors are. So we'll calculate that as well. I won't let you pass away with that. We'll calculate cos theta for this very example, and we'll use our own calculator, which is Python. We won't use our scientific calculators, but we'll use Python to calculate for this given example what the cos theta is going to be. Okay. And again, I want to recap a little bit and tell you why we are doing this. Why we are doing this is because we are trying to make a recommendation engine based on similarity of contents. So today's workshop was building a movie recommendation engine. So to do that, we need to have some features which are present in movie A, and some features are going to be present in movie B. And to find similarity between these two contents, we need to have we need to quantify the similarity, or how different or similar these two movies are. And to do that, we are going to use a measure called as cosine similarity, which is the cos theta between these two vectors. And to do that, let's see how we are going to use it and calculate it in Python. So now this is a good time to go into the hands-on part of the workshop. We are running a little bit behind time, so I'm afraid we'll see how it goes. We'll try to be quick as we can, but if I run a little bit over time, please forgive me. So let's go ahead and get started. I would ask all of you to open your Sublime Text. I had asked you guys to install, recommended that you use a script editor such as Sublime. So I'm going to open my Sublime Text. So open Sublime Text. Let me close all these things. And I'm going to say file, new file. Okay. And now you can save this file in a location that you want. So let me go ahead and actually first create on my desktop. I'm going to create a new folder. I'm going to create a new folder called Code Heroku. So create a new folder somewhere where you would like to work on. And within this folder, in this folder desktop Code Heroku, I'm going to save this file. So I'm going to say file, save as. I'm going to say the file name as, let's say, cosine similarity.py. Okay. All right. So we have saved this file as cosine similarity.py file. Now I'm going to wait over here till everyone tells me that they are over here and they have opened a blank Sublime file over here and saved the file as cosine similarity.py. Okay. What we are trying to do is trying to find this cos theta between these two vectors. We are going to use Python to do that. And I want you guys to open Sublime Text or any other script editor that you're comfortable with. Open it, save the file as cosine similarity.py, and let me know in the chat box once you are there. Yeah, Vishwajit, even Atom is fine. Just use any script text editor that you're comfortable with. All right. So once you are over here, let's start with the two sentences that we have. So we are gonna say text is equal to. We are gonna create a list of the two sentences. The two sentences, or no, the two text strings that we had over there were London, Paris, London, and the second one was Paris, Paris, London, right? So we have this text over here. Okay, we just created a list of the two text items that we had. Okay, now I'm gonna give you a hint. Okay, the next thing that we want to do is count these words. So we need to come up with something like this guy over here. So we need to have London 2, Paris 1, London 1, and Paris 2, right? So we need to find the count of each of the words in these two text items. So we need something like the final output of our next step should be something like 2 comma 1, because London is 2 and Paris is 1, and we're gonna have something like 1 comma 2 because London is 1 over here and Paris is 2. So we need to find something like come up with this, and you could do this using a for loop, and you could write a pretty simple logic to count how many times this word is coming and come up with a 2D array like this towards the end. But this also happens to be a very pretty basic operation in a lot of machine learning problems. So Scikit-learn has an implementation of what we're trying to do over here. And if some of you have attended a previous workshop, you know that I'm not going to tell you how to do this. I want you to go to the Google and find Ask Larry page. How can we use Scikit-learn to come up with the count of these words? So go ahead and search on Google, because our basic philosophy is that you need to be able to do these things by yourself. We are just trying to show you, how to fish, and we are not trying to give you the fish itself. So go on Google and find out how will you use Scikit-learn. Most of you have told me that you have installed Scikit-learn, so hopefully you have. So go and search on Google, how will you use Scikit-learn library to find the word counts from these sentences. Okay, I'm gonna wait for 2 minutes over here and I'll let you guys find out, and someone needs to tell me on the chat window which class or which method you're gonna use to come up with an output like this. So again, my question is, how will you use Scikit-learn? So we need to come up with a 2D array like this, right? You could do it using a for loop, or you write a very basic logic to come up with a 2D array like this. But this happens to be a very common operation in machine learning, and Scikit-learn has an implementation on how do you count and keep a track of these items. So why don't you go ahead and search on Google, how will you use Scikit-learn library to count the number of words which are present in these sentences. Not just number of words, but their frequencies as well. So Suman says we should use CountVectorizer. So Biswajit, cv.fit is a method and it's not an object, okay? So, all right, so let me go ahead and search on Google and let me show you how I would go about doing that. So let me go over here. So what I'm going to say is, the first thing that we always say is the name of the library or the language. So I'm going to say Scikit-learn. The next thing that we want to say is find count of words in text. So the first thing over here is a Stack Overflow answer, but what you could do is directly go over here and go to the Scikit-learn library documentation as well. So I'm going to click over here. So seems like something is wrong with their server and the website is not coming up for me, but let me show you how we would go about doing that. So once that documentation loads up, what you're going to find is what Shanmugh said over there is, there is this class which is called CountVectorizer from Scikit-learn. So what you could do is, first we need to import that class into our Python program. So we are going to say from sklearn dot feature extraction, and again, where are we getting this from? We are getting it from their documentation. If it loads up, you see it's right over here. So let me try to copy this. Right, so this is the name of the class over there, right? So this is how I would go about doing that. When I see that this is a class which exists, so I'm going to say from sklearn.featureextraction.text, I want to say in the last part over here, I'm going to say import CountVectorizer. Okay. So once I know that this class exists, which is CountVectorizer, I need to initialize an object from this class. So I'm going to say CV is equal to CountVectorizer, right? And once you have that, let me just get rid of this. I wanted to show you the documentation for CountVectorizer, but unfortunately it's not coming up. There is a method in there which is fit and fit transform. There are two methods of this class, and we're going to use the fit transform class to count the number of texts. So we're going to say count matrix is equal to cv.fit transform. And again, I'm not getting this by magic. If only I could show you the documentation. There are two methods in there which describe how you could use the CountVectorizer to count the number of frequencies of these words. Okay, so once you have this, what you could do is let's print out count matrix and see what do we get. Save it and run it. You can run this using Control+B if you are on Sublime Text. Okay, the first time it might take some time. So we got something like this. Okay, again, this is not exactly represented by the way that we were looking for, but what this is giving us is a matrix which is of type CV sparse. So what we could do is to show it in more a familiar form, we could say dot to array, and this is going to convert this to a NumPy array and then display it. And let's see. Yep, so this is what we were looking for. This has the counts of these two words in both of these sentences. So this is saying that in the first sentence, London has 2 times, Paris is 1 time. The second sentence, London is 1 time and Paris is 2 times. So over here, when I printed this was another object which is Scikit-learn's internal representation of a sparse matrix. What it is saying at 0,1 location, the value of that matrix is 1, 0,0 it's 2, 1,1 and 1,0. So it's difficult to visualize that way, and that's why to print it out in a more familiar way, I said to array over here. Okay, so what that gave us was a representation like this, which we are more familiar with. Okay, does that make sense? Does anyone have any question? Please stop me over here if it's not clear. Okay, should I move ahead from this point? Please message me on the chat and let me know. Is everyone clear until here? we created the counts, we got the counts from of these words from these two sentences using the CountVectorizer class, and we used the fit transform method to do that. Okay, so once you have this, the next thing that we want to do is find the cosines, right? We got this matrix representation. The next thing that we want to do is find the cosine similarity, right? We need to find the cos theta between these two vectors. So we got these 2 points, 1, 2 and 2, 1, right? Now we need to find the cos theta over here. And again, Scikit-learn is going to give us the implementation of this distance. So why don't you go ahead and search on Google what method that you will use from Scikit-learn to find the cosine similarity between these two vectors. Okay, so you could search for the exact same thing that I just told you, and that will give you the name of the method. Let me know in the chat box which method from Scikit-learn library will you use to find the cosine similarity between these two vectors. So guys, again, my question is, which method from Scikit-learn library will you use to find the cosine similarity between these two text contents? Yep, Soham and Suman both got it right. So why don't you guys try it? So go ahead and try it in your programs. Use the cosine underscore similarity method from sklearn.metrics.pairwise. So let me go ahead and search for others as well. Here's what here's what you would do. So I'm going to say Scikit-learn cosine similarity, and you want to just say between two vectors. Okay, so again, over here you have the name of the class and the method. Hopefully it opens up for me. I don't think so it's gonna open up this time again. I'm not gonna try that. Okay, let me just copy it from over here. Okay, so I'm gonna copy this. I'm gonna paste it over here. I'm gonna say from sklearn.metrics.pairwise. In the last part, I'm gonna say import. Now again, this is not a class, it's a method directly. So you don't need to initialize an object like this. Okay, so directly you could say over here, let's just comment this print statement. We don't need this. You could say similarity scores is equal to cosine similarity, and we're gonna say pass the count matrix over here, right? The count matrix has the number of counts of these words. Okay, so we're gonna pass the count matrix, and then let's just print the cosine, the similarity scores. Print similarity scores. Save it and do a control B over here. Let's do a control B and run this, build this. And we have something that looks correct. What this is saying is the first sentence is similar to the first sentence 100%, right? London, this text will be similar to itself by, definitely it's similar to itself, right? So it has 1. The first sentence is similar to second sentence by 0.8, a cos theta of 0.8, okay? And again, it is gonna be a symmetric matrices because no, the second is going to be similar to second, and if first is similar to second by 0.8, second is similar to first by 0.8 as well, right? So we got the similarity scores. Now what we were able to do is we were able to get a numeric, or no, we were able to mathematically quantify the similarity between these two pieces of content, right? So once you are over here, let me know in the chat box. If there are any questions, please ask me. If there was something not clear, if I went too fast on something, please let me know, okay? Sure. So Sanmukh, what we are trying to do is to quantify how similar these two pieces of content are, right? So what we did was we said that we could draw two vectors in this space over here, right? And between these two vectors, we know that there is one which is Euclidean distance and the other is the cos theta. Euclidean distance is pretty easy to compute. We already did it. We said that it is √2 over here. Cos theta is a little bit more complicated. So what we said that let's just try it out in Python. So we came over here. We said we first got these two vectors 1, 2 and 2, 1 using the fit transform and CountVectorizer class. Once we had that matrix of 1, 2 and 2, 1, what we did is we said use the cosine similarity or find the cos theta for these two vectors. So Scikitlearn has given us an implementation to find this cos theta, and we're going to say similarity scores is equal to cos theta, and we pass the count matrix to it, and this is what we get in the result. What this is saying is the first text is similar to first text 100%, right? This sentence over here is going to be similar to itself definitely, and it is similar to second sentence by value of 0.8. The cos theta between the first sentence and the second sentence over here is 0.8. Okay, does that make sense now, or is there something which is not clear or something which is I'm not able to convey? Okay, so with that we were able to give a similarity, quantify the similarity between our contents. I have a quick question for you again over here. So let me do this quiz first because we just did it. And Grusha, I'll come to your question on which is better, when to use Euclidean and when to use cosine. Okay, give me just 1 second over here. A quiz for you guys. Answer in the chat box over there. Given the similarity matrix below, which movie is most similar to movie 0? So over there we had just two words. So we had a matrix of 2 by 2. But now we have 4 movies over here. So we have a 4 by 4 matrix. So my question is, given this similarity matrix, which movie is most similar to movie 0? So we are trying to come up similarity for movie 0. So just focus on this row. Okay. So 0 is similar, movie 0 is similar to movie 0, definitely 100%, right? Next, what, given these similarity scores, what is the next most similar movie? Movie 1, right? Movie 1 has a similarity score of 0.8 with movie 0. As simple as that. Movie 2 is just 0.2 and movie 3 is 0.5. So the right answer to this is movie 1, because it has movie 0 and movie 1 have 0.8 of cos theta of 0.8. Okay. So given that, I hope that you understand that part, and what I'm going to do is answer a question that Grusha had, when to use an angular distance versus when to use Euclidean distance. So here is an example over here. So given an example over here, focus on these 3 points first, the blue, orange, and the, I would say, saffron, I guess. So these 3 points, these are on the x-axis we have the weight, and on the y-axis we have a length of a person, weight and the height, I guess. And what we are trying to classify is whether this person is a young or he is a mid-age or he's an adult. Okay. So these are the 3 points. So given these 3 points, if someone has asked you that to classify whether this gray point over here, where would you classify it into? Is he a young person? Is he a no, a mid-age, or he is an adult? So my question to you is, someone has given this graph to us, okay, and there are 3 points over here, okay. These 3 points belong to a young person, a mid-aged person, and an adult person. And now someone has given a 4th point. So where would you classify this person into? Would you classify them as a young person, or would you say that he's a mid-aged, or is he an adult? You know the length and the weight of this person, which is somewhere over here. And we were told that someone who has length of this range and weight of this range is a young person. Someone who is over here, length of around 6 and weight of around 6, he is a mid-aged. And someone who is over here with a length of more than 10 units and weight of more than 10 units, he is an adult. Okay. Now, given this world, or given this scenario, someone has given you a 4th point. How would you classify them? A young person, right? And based on your intuition, you said that because you could like literally see in the graph that if he is his weight is less and his length is less, he should be over here, right? So in this case, should you, and let's say now if you are trying to tell your machine learning algorithm how to do something that you just did, right? So Brusha and Suman, both of you did something intuitively. Now we are trying to teach our computers to do this. So we need to talk in terms of numbers now. If you use angular distance to calculate where this gray point should lie, you will end up saying that this person is a mid-sized, mid-aged person or an adult person, because the angular distance between these two, if you draw a vector from here, these are going to overlap, right? So angular distance will be less over here. It will be close to 0. So you're going to think that this vector and this vector are going to overlap. They are going to be very close. So you're going to think that this is a mid-aged person. But no, the correct answer to this is no, he can't be a mid-aged person, because their weight and length are too small. And in that case, this is a perfect scenario where you should be using a Euclidean distance between the two vectors over here, right? Because if you take the Euclidean distance, this distance is smaller over here between these 2 points than these 2 points, right? So this distance will be much more bigger. So in this case, you should not be using angular distance, because if you use that, you will end up thinking that this point over here is closest to this point in angle. But if you look at the context, and many times in machine learning, you can't just rely on the numbers. You need to understand the context as well. The context in this case is, this is the length and the weight of that person. You can't just rely on the numbers over here. You need to find the Euclidean distance between these 2 points to classify whether he is or they are an mid-sized, mid-aged, or a young person. Okay. So a quick quiz for you, just to check whether you understand that part properly. Answer in the chat box, or let me just do this. I have the second quiz over here. So I'm going to launch this poll. Most of you have got it right as well. And the answer is the second one. When you're trying to compare the similarity between two documents, or there, what is going to happen is, if there are more number of words in document than document 2, finding Euclidean distance won't help much. All you are concerned with the occurrence of a word and not how many times that word occurs, right? So in that case, it's more useful to use cosine distances rather than Euclidean distance. Okay. All right, so let's get into the second part, which is more interesting. We're going to build the movie recommendation engine. We're going to use a movie data set from IMDB and build our recommendation engine. This has the movie data set as well as the starter code that we are going to use today. So I'm going to go over here and hopefully I can get the chat window. Okay. So guys, please go ahead and download this and unzip it in the folder that you were working in before. So I'm going to take this zip file and download it. Once you have downloaded it and unzipped it, let me know in the chat box. Okay. So I'm going to take this movie recommender.zip, cut it. I'm working in this Code Heroku folder on my desktop. I'm going to go over here, Code Heroku, paste it over here and unzip this file. Make sure you unzip it. Okay. And I'm over here. So reach to this point where you see these 2 points in your folder. You have downloaded and extracted it, and let me know in the chat box. All right, so seems like most of you are getting over there. And the data set that you see over there right in front of you, movie_dataset.csv, it is created from IMDB movie dataset of 5,000 movies. It's relatively a smaller file. A lot of movie datasets that you will find are a lot bigger, but because I wanted to just show you guys and get a knack of how these things work, I gave you a smaller data set to work, but in no ways is any different from any other that you might find. But the only thing that I've done to that data set is I've cleaned that data a little bit so that we don't waste a lot of time pre-processing that data in our Python code. I think it will be a topic for some of our other workshops where we see how you would pre-process or clean up the data that you might get from internet. But for today, the data set that I have given you is pretty clean. Don't try opening up in the notepad, otherwise it will get stuck. It's relatively a big file for a text editor to open. Okay, and thus we have Python and our pandas and our data frames to work with. All right, so we're gonna open this data set. Open the movie recommender.py file. So you could go here and say open with Sublime Text. And this is a starter code that I have given you. I've given you steps on how we are gonna go about implementing this. These 2 lines are the same lines that you used just before, that we used from the Scikit-learn library. And these are 2 helper functions which are given to you. Don't worry about them right now. As I have said over here, use them when needed. Okay. So let's start. Let's get into this. If you want to have a look, just have a look at this. I'm going to wait over here for 1 or 2 seconds and have a look at it. Try to understand what are the steps, and if there are any questions, let me know. Just skim over it. If there are any questions, if something is very much off, otherwise I'm going to go into the details on how we're going to do each of the steps. So again, can someone tell me what type of recommender system are we implementing? Just to check whether you guys are with me on this. So what's the type of recommender system that we are implementing today? We saw there were 3 types. Yep, Santosh got it right. Content based, right? So we are gonna look at the content of our the movie data set that we have. Within the content, we'll come up with similarity of that movie. And then, so again, in the content based recommender system, we need to take something from the user. We need to know what a user likes, and then we'll recommend him movies which are similar to this movie. And that's how we're going to go about doing this. All right, so let's get into step one. We have done this several times before in our previous workshop. For those who are new, Google it. How will you read a CSV file using pandas? So using pandas library, we need to read the CSV file into our object, which we call as data frame. We need to get the contents of this CSV file in our data frame. And how do we go about doing that? Which method are we going to use from the pandas library to read a CSV file? So Suman thinks it's read underscore CSV. Can someone else go and look it up on Google and see if that is correct? Yep, so that is correct. And we already have that statement, import pandas as PD. So we can directly go over here and just say data frame is equal to, we need to say PD dot read underscore CSV and our dataset name, which is movie underscore dataset dot CSV, right? I hope I got the name correct over there. Yes, it's there is no S over here. It's just movie underscore dataset. Okay. So save it. Let's print our data frame and see what do we have. If we got it correctly, we're gonna say print data frame dot head, which is gonna give us first few rows of this data set. We are trying to just see what did we get, if we got it correctly or not. So save it, Control B, run it and see if we are getting something. First time again, it will take some time. After that, it will be faster. Right, so we got the movies. There are some columns over here, and to get these columns, we could say df dot columns as well. Okay, let's see. Is it a method or is it an attribute? Let me see. Okay, so df dot columns. So in this data frame, we have these many columns or these many features, right? So from these features, today we are gonna select a few features to implement our content-based recommendation system. Okay. So I'm gonna say, okay, so once we have the data frame, we have read our CSV file. What we want to do is we're gonna select some features from this. So let me just show you all the columns over here. We have the budget of that movie, the genre, the homepage, the keywords, original language of that movie, title, production countries, the vote counts which are given by the users, their cast, the crew, and the director. Lot more than what we need, I guess. And you can try out different features as well. And you might get some errors while you try to do that, because the features that I'm going to use today, I have done some pre-processing on them to clean it for you. But if you try to pick some other features, you need to pre-process that data as well. Okay, so if there are any null values, or if there are any missing values, you need to take into account those things as well. But for today, we are going to select these features. We are going to say features is equal to, I'm going to say, let's select the keywords, right? Keywords of this data set, or no, from each movie. I'm going to say cast. I'm going to say the cast, and I'm going to say the genre. And I'm going to say the director, because if you like movies from one director, most likely you like other movies from that director as well. Okay, so looks good. I'm just making sure I named all my keywords is correct. Cast is correct. Is the genre correct? Do we have a, yep. That's correct. All right. So once I have selected the features, what we want to do is create a column in data frame which combines all these selected features. So just like in that text in this program that we created, everything was inside this one element, right? But right now we have things which are scattered across these 4 columns. So we want to create a new column which combines all these columns. Okay. So how would you go about doing that? So this is not very straightforward if you haven't done this before. So what I'm going to do is, let me just give you something over here. So what we're going to say is, let's define a function which we're going to call it combine features. Let me make sure you can see this properly. Okay. And this combined feature function takes a row as input, a row from our data set as input, and this returns the row of keywords, right? So we need to get the keywords from that row. We're just gonna add it. I'm gonna say plus, just added a space over here. I'm just gonna combine all the features together in a simple Python operation. I'm just gonna say row of cast. I'm gonna say plus row of, I'm just, all I'm doing is just creating a function which takes in a row and combines all its rows together and then returns it. Sorry, not that all its rows, but combines all these features together in one string. You're just creating one big string, which is combination of all these smaller columns. I'm going to say plus row of director. I hope I'm not missing anything over here. If I'm missing something, it's your job to tell me if I'm doing something wrong. Okay. Okay. So we have this function that takes in a row and combines all these parameters from that row into one giant string. Okay. So now what we need to do is actually use this function. We haven't called this function yet. Okay. So now this is something which you could find on Google. What method which you will use to on the data frame to apply this function to all the rows of that data frame. So search on Google how to apply this function or this transform to all the rows of that data frame. So Santosh thinks it's iloc. So Subin got it right. We need to use the apply method on axis 1. So let me just show you how we are going to write that. So we need to say data frame of combined features is equal to data frame dot apply. We need to apply this method, which is combined features. We just created this function over here, right? We just defined this over here. So we need to apply this, but now this is gonna do row wise, right? So it is gonna pass this, it is gonna combine it horizontally, but we need to combine it vertically over here. So we're gonna say axis as 1. So this is gonna pass each row individually and not columns. Okay. So once you have this, let's see what did we get in the combined features. So we're gonna say print data frame of combined features. Let's see what are we getting over there. Okay, and we don't want to print everything, so let's just say head over here. Okay, so let's see what do we get. Let's comment out any other print statements. I don't need this. We saw what the columns are now, so let's see if we get the combined features properly. Combined features over here. I was missing a D over there. Combined features, I was missing this over here. So we are getting an error over here, and we need to troubleshoot this. So we seems like we were able to apply it, but now the error that we are getting over here is this, which is, you know, when it is trying to combine these features, there is some error which it is telling us that you're trying to combine a float with a string, but you know, as per our knowledge over here, none of them should be floats, right? A director or a genre or a cast or a keyword, they can't be floats, right? Everything has to be a string. So what's happening over here? Can someone tell me what would you do to troubleshoot this problem? We need to find something. Why is this no, the line that we have written over here is not working properly? So what should we do over here? So can someone give me some ideas on how we would go about troubleshooting this? So try it out. Biswajit, what happens if you typecast everything to a string? Does it work after that? So what I would do is, first thing is, I want to know what is happening in this row when it fails. Okay, so what I'm going to do over here, let's get rid of this first stupid thing over here. Okay, let's close this out. Now what I need to do is I want to try this operation and then accept any errors and then print that row out. Okay, so now I'll know what is wrong in this row when it fails. Okay, and guys, I just wanted to make sure that now I walk you through different scenarios on where things might fail for you. And that's why I'm showing you how I would go about solving these issues, so that when you come across them, you try to get a knack of how you should go about thinking about it. Okay. So I'm going to print this row out and see where is this error coming from. Okay. Save it, build it. Okay. Seems like I have printed it out. So we said error over here on line 71. The budget, the genre seems to be fine. Homepage, we are not using ID keywords. But what's wrong with the keywords? We are getting a nan over here, which is not a object that we are expecting. We are expecting a string over here, and seems like a lot of times in this keyword features we are getting a nan, okay, which is not a number. So what we need to do is we need to get rid of all these nans from our features. Okay, from all our columns we need to get rid of all our nan values. Okay, so what we could do is, let's come over here on the top. Before we combine these features, I want to say, for a feature in features, for all our feature in features, I want to say data frame of feature of that feature. Sorry, so this needs to be this one. I want to iterate over all of these things: keywords, cast, genre, director. Data frame of that feature is data frame of that feature, again the same thing, dot fill NAs. So okay, the fill NAs function is gonna fill all the NAs with the thing that you give over here. So I'm gonna put a blank string over here, or just an empty string. So what this loop is gonna do is go over all these features that I want to use, okay? And inside this, it is gonna modify this data frame and fill all the NAs with an empty string, okay? Save it, run it, and let's see if we get it right now. Seems like it is working now. We didn't get those errors printed out. If we had any errors, this would come up, but now we don't. So this print statement, so let me just say combined features, right? So this is what we are printing out. We are printing the combined features out over here: culture clash, feature space, colony, okay? So we got all our features in this one giant column, which combines all these columns together, okay? So once you are over here, let me know in the chat box and let me know if you have combined all your features together. So Suman, you could try doing that in place as well. We don't need this in place because we are reassigning it over here as well, right? So if you are not writing this, then you could use in place, or no, it's one and the same thing. So guys, let me know once you have reached this part and you have combined all your features together in this new column that we created, which we are calling combined features, okay? And for those who are done, we have already done the step 4 and 5 in our previous program that we just wrote. Can you go ahead and complete the step 4 and 5? So in the previous program, we already have seen how to get the count matrix from list of features that we have over here, right? So we could create, again, we're going to use the same thing. Let's just copy it from here. I'm going to copy this thing from here to create my count matrix. And I'm going to say count matrix is equal to cv.fit transform. Instead of text over here, we have data frame of combined features thing from here, right? So we are going to say data frame of combined features. Okay. Save it. And once you are over here, and then we need to have, once we have this count matrix, we can get the cosine similarity, right? So what we could do is cosine sim is equal to, let's just say cosine sim over here. And we're going to say cosine similarity. Oops, what did I do? Of count matrix, right? So this is going to give us the similarity scores of all the movies, right? So once you are over here, let me know if you have completed this part, and then we are going to do the last 2 or 3 steps which are remaining. The movie that the user has been given to us, which is Avatar. And what we need to do is get the index of this movie from the data frame. We already have a helper function for us. So we have the similarity scores that we have built using our cosine matrix or cosine similarity scores that we have. So this is what we have in the memory right now. We have these movies and this matrix of similarity. What we need to do is, given a movie on this row, let me just get my pointer. So given a movie over here, let's say I want the similar movies for movie 2. I want to list all the remaining movies in descending order, right? Because let's say I'm in this row over here, let's say row 0. I'm in row 0 over here. So I want all movies which are similar to movie 0. So what I need to do is return the indexes of all movies, the indices of all movies in descending order. So I'll return over here. First, the first index that I'm going to return is obviously 0, because movie 0 is similar to 0.
Then I'm going to return index 1. Then I'm going to return index 3 and then index 2, right? So let's see how we are going to do that. To do it in Python, what we're going to do is the first step is to get into this matrix. So the first step is to get the index of that movie from its title and get this row. So let's say if we want for movie 0, the first step is to get this row itself, right? So we are getting this row out from this matrix. So we got this row, which is 1, 0.8, 0.2, 0.5. The next step that we are going to do is we are going to enumerate this list. And a lot of you have told me that you are pretty at an intermediate level in Python. What we need to do is keep a track of indices of all these elements. So what we are going to do is enumerate on this list. So we are going to say, so this is going to convert this list of elements into something like a list of tuples, right? So once you have this list of tuples, what we're going to do is we need to sort these tuples based on the score which is over here, right? So this thing needs to move over here and this thing needs to come over here, right? So we need to sort these list of tuples based on the similarity scores. And once you have that, now this is a sorted list. Now, if someone gives you this list, you can easily tell for movie 0, the most similar movie is movie 1 because it is at this element. The next most similar movie is movie 3 and then movie 2, right? So this is our final expected output that we are looking to get from the operation that we need to do in the next step. Rusha, to answer your question, so again, handling these missing values is always a challenge in machine learning. What do you do with these values? Do you replace them with empty string? Do you discard the entire record? It's up to you as a feature engineer or as a machine learning engineer to decide what is giving you better results. Do you want to just discard that entire movie? You don't have the feature list over there, right? So do you want to discard that entire movie from your data set and you don't want to learn about that movie, or no, you want to add something else? But again, that's always a challenge and you need to decide, do you want an empty string? Do you want to fill out with random values? Well, you could also do a random value over there, right? Just put a random huge string over there instead of just empty strings and then see if you get better results. Okay. There is no right or wrong answer to that. There's always an art over there. Okay. It's a craft. Next thing that we're going to do is get the index of that movie because we need to index into that matrix. So we need to say, and I have a helper function which is given over here. So which is get index from title and get title from index. And it's not rocket science. If you look at it over here, you will understand pretty much very easily what I'm trying to do over there. So what I'm going to do over here is get the index of that movie. So I'm going to say movie index is equal to get the index from title, and I'm going to say movie user likes, and I'm going to pass this. So this is going to give me the index of that movie. The next thing that we need to do is find all the similar movies, right? So similar movies. Now the first thing that we did over here was we went inside this matrix. So let's go to the index, movie index inside this matrix and get this row out. Okay. So we're going to say, and go inside this matrix, which is the cosine sim matrix. We're going to go at the movie index. Once we are inside this movie index, what we said is we want to enumerate on this list. And how do we do that? We're going to say, we're going to convert this to a list and then we're going to enumerate it. Okay. And save it. So this is going to give us this list of tuples over here. So this list of tuples, the only thing which is remaining now is to sort it right? So we need to sort this in list of tuples. And guys, again, I'm sorry that I'm going over time, but we are just left with last one step over here. Now we need to sort this list of tuples from based on this value over here, which is the second value of that tuple, right? So what we're gonna say is sorted similar movies is gonna say sorted. Again, it's standard Python functions that we are using over here. I'm gonna say similar movies. I'm gonna pass similar movies over here. Next thing that I want to do is give a key on where it needs to sort. And this key is actually what we need to pass is the second element of this tuple. So we'll have to use a lambda function over here. I'm gonna say lambda, and I'm gonna say pass x, give me x of sort by x of 1. Okay. And the other thing that I'm gonna say is reverse is true, because I want it in descending order, right? Most similar movies should come up first, and save it. So we did the step 7 as well. So we are over here. Oops. And the only thing which is remaining now is to print all these movies. So we are gonna say for a movie in sorted similar movies. Now we have the index of those movies in that tuple over here, right? We need to print the title. So print get title from index, and we need to pass the movie of 0 has the index over here, right? So the movie, this is the list of tuples that we have in similar movies, and we are passing the 0th element of this tuple. So we are passing the 0th element of the tuple from there. So this is what we're going to print, and this is going to print for the entire matrix, but we want only first 50 similar movies. So let me just keep a track of count. I'm just going to say I is equal to 0. And there are other ways of doing it. If you find a better way, or if you are more comfortable with something else, I like to keep it very basic. So I'm going to say I is equal to I plus 1. And if I is greater than 50, just break out of this loop. As simple as that. So let's see, let's save it and run it and see if it works. And we were able to get the name of our movies. So as we expected, the first movie which came up was Avatar, because Avatar is similar to itself, definitely. And the second one was Guardian and Galaxy, according to our program, Aliens, which seems pretty correct, right? Because all these are space and action movies. So this is what you would expect if you type in Avatar in here. So we were able to get a list of all movies which this user might like if he tells us that he likes the movie Avatar, right? So reach to this point and let me know if you face any errors or if you have any questions. I also have a quick assignment for you. Santosh, what we are trying to do is we are trying to print all the similar movies, right? So this sorted similar movies is this array right in front of us, right? So this last array that this last list that you have in front of you over here is what we have in sorted similar movies. So this sorted similar movies has indices of all the movies and their scores. Okay, so what we need to do is go over this entire list, get the title, because if you print the index of that movie, it doesn't help the user, right? If you print 0, 1, 3, it doesn't help the user. We need to print the title. We have a helper function which is gonna get the title from the index, right? And yeah, that's it. We just need to go over this entire loop and get the title based on the 0th element of this tuple over here. right? So what we're going to say is come over here. We're going to say for a movie in sorted similar movies, print get title from index, and we pass the 0th element of that tuple, right? If this is confusing you, you could just say element over here, right? So if this is element, right? So this element is this tuple which we have over here, right? So you guys need to submit this assignment to our email address, which is hello@codeheroku.com. If you have any doubts, questions, please feel free to email me over there, or my number is over here as well. It's right over here. There are 2 exercises that I have. The first one is the scientific paper reading. There is a paper that I want you guys to read, and there are some questions based on the paper. Hopefully that will help you to get a better sense of recommendation systems. And the second one is a programming exercise, and it isn't any complicated. It's just that checking how good of understanding you got of today's class. So implement a hybrid recommendation system which uses the vote count and vote average features from our data set as well, right? Because we didn't use those 2 features, but let's say if there is a movie which is very popular, you want to have that higher in your recommendation list, right? And which additional features would you use to improve the recommendation system? So thanks for attending, and I hope you guys enjoyed. Please subscribe to our YouTube channel if you haven't already done so, and that will also, and tell your friends about us, bring them along in the next workshop. Thanks again for attending today's workshop, and I'll see you in the next class next Saturday.